For section 1.4, we're going to be talking about sketching graphs, giving some key information, stuff like this. They might tell you something about the domain or the range or the intercepts. They might tell you something about the behavior of the ends. They might talk about maximums or minimums, extrema. The ones that we haven't highlighted a lot are increasing and decreasing, which means as you read a graph from left to right, is it going up? Is it going down? And also positive and negative intervals, basically where are you above the x-axis is positive y values, and where the graph is below the x-axis, those are negative y values. So we'll look at all these things that they might give us to draw the picture. So I realize here I already have the picture because it's easier to do ahead of time, but let's kind of just go through how I would do this. So 0, -7, I would plot that point. That's my y-intercept. It is linear is what they're telling me. The linearity, yes, it is linear, so I know it's either going to go up or go down. It's positive for values of x such that x is less than -3. It's a little bit trickier. I could go to maybe some other details, like first go like, oh, for all values of x, it's decreasing, so it must be going down because this would be positive. It's increasing here. It must be a line like this. And the end behavior confirms that as x gets bigger, we're going to more negative infinity, we're going down. As x gets more negative, we're going up. So it confirms this shape. So I would go back to this piece. Okay, for values x less than -3, x less than -3, so that's this side. Everything here needs to be positive. So this side of things have to be above the x-axis, and everything beyond -3, so like -2, -1, 0, would have to be negative. And then I would just draw the lines from there. This one's actually pretty easy because they gave you the x and y intercept and they told you it's linear. So I could literally go to -1, 0, and 0, 2, watch the scale, and I know it's a line, so I would just draw it from there. It's continuous for the whole thing. Positive x greater than -1. So here's where we're at -1. Right here we're at 0. Just same thing here. This is 0. This section up here is positive. This section is negative. Right here we're at 0. So this section, everything beyond bigger than -1 is positive, and everything before -1 is negative. It's increasing for the whole time, so you can see it's going up, and the end behavior confirms that as well. We can also do this for nonlinear, a little bit trickier. So I know this one's going to be nonlinear is what they're telling me. The linearity is nonlinear. So it's maybe be a parabola or some sort of cubic graph or curve. Okay, let's start with this y-intercept of 0, 3. Okay, we got that. I put a point there. It is continuous, so not like broken up. It's positive everywhere. So I know the entire curve, whatever it is, has to be above. So it's likely both ends go up. We can kind of look at the end behavior for that too. Both of the y values are always going up. So it's got to be some sort of parabola. So I'm kind of like starting to get the picture. It's decreasing when x is less than 0. So here's when x is 0. So everything less than 0 is decreasing. I know that looks like it's going up, but we read from left to right. So as I go left to right, this is actually decreasing till here, then increasing. We also got a confirmation there's a minimum at 0, 3, so I see this is the lowest point. So it goes down to the lowest point and then back up. All right. There's one more here. And again, feel free to pause and try to sketch it yourself, or I'll just go with the x-intercepts at 1 and 3. There's a y-intercept at 0, -3, so I get some free points. It's nonlinear, so maybe some sort of parabola or other curve. It's continuous, so not broken up. Now, symmetry we didn't really touch on a lot, but symmetric with the line x equals 2. So that does tell me, like, when I go to x is 2, so right here, if I drew a line, it's symmetrical. So if I have one point on one side, I have the same thing on the other side. For example, that y-intercept. I know if there's a point here, there'd be a mirror image on this side. Okay? Let's see what else we got. It's positive between 1 and 3. So between 1 and 3, it's going to be above the y-axis. Everywhere else, it's negative. Less than 1 and greater than 3, it's negative. That's giving me some hints. It's increasing for x is less than 2. So right here, 2. Look, I know that looks like it's going down, but left to right, it's increasing, gets to the highest point at maximum of 2, 1, and then goes back down. Which, by the way, just jump around to different themes. Like, any points they give you, try to plot those, and then you can go back through and check off these other lists, make sure it meets all the criteria. Like here, both of the y values are going down, so I know it has to be this kind of behavior. That's all. We do this with real-world situations. So we get this test driving a car. She's thinking of buying. She decides to accelerate to 60 miles per hour and then decelerate to stop to test acceleration and brakes. It takes her 15 seconds to reach her maximum speed. So we got kind of keywords in there. And 15 additional seconds to come to a stop. So like kind of get some ideas of time. 15 seconds and then another 15 seconds. So 30 seconds all total. Start to think about that. And let's see what we got. So y-intercept, she starts her test drive at 0 miles per hour. So we got different times and different speeds. So yeah, at time 0, she's going 0 miles per hour. It's non-linear in this case here. I know these look like lines, and they are, but this would actually be like an absolute value function. It's one line, then a second line. Okay. It's increasing at a uniform rate for the first 15 seconds. So I know it's going to go from 15 seconds is her maximum speed here. So 15 and 60 miles per hour. So it was uniform. She was accelerating and then she was decreasing at that same uniform rate here. So another 15 seconds puts her at a stopping at 30 seconds all total. Because she starts at 0 miles per hour and ends at 0 miles per hour, there is no end behavior. We start and stop. There's no arrows, so we can't talk about the end behavior here. Before sketching, you can always consider these constraints. She cannot drive a negative speed nor have negative time here. So that's why we only are here in the positive X and Y axis.